We now turn to our plenary speaker of the afternoon session, and I'm very pleased to welcome Associate Professor Jacqueline Beggs, who's Director of the Centre for Biosecurity and Biodiversity at Auckland University. She's also a member of the Biosecurity Ministerial Advisory Committee, and she'll be telling us a little bit about the extent to which biosecurity might be failing our natural ecosystems.
Ka tangi te titi, ka tangi te kaka, ka tangi hoki ahau. Ti hei Māori ora. Tēnā koutou, tēnā koutou, tēnā koutou katoa. Ko putoa ki te monga, ko whakatāne te awa, ko ngā te awa te iwi, ko Jacqueline Beggs ahau. Tēnā koutou. This is my great-great-grandmother, Mera, and it's a painting of her in about 1850. And it was a time when New Zealand was quite a different place. And so the bird song is not obviously taken from 1850, but it's kind of a little bit of a recreation of, to represent that New Zealand was, the land sound was of birds. It was a forested landscape, and it was dominated to a large extent in terrestrial by birds. These days, if you go into our forests at the wrong time of the year, you've got the sound, please, bucks. This is more like what you would hear. You might just need to click the button. I don't think I can do that from here. Just up the sound. Yes. So anyone that's been into South Island forests at about this time of the year, actually, this is more likely what you'll hear rather than birds. Of course, if you go into other parts of the landscape in New Zealand, this is what you'll hear rather than birds. So there's been massive changes in landscape across New Zealand. If you're really unlucky, you actually go into parts of the country at this time of the year and you get both. You get the sound of cows, and with the arrival of the giant willow aphid recently, which is infesting willows in many areas, and you've got massive amounts of honeydew, which has led to higher numbers of wasps in these areas. So we've kind of got an invasion meltdown, if you like, where you've got multiple things going on in the landscape and suddenly you've got all sorts of problems going on. There we go. Oh, yeah, I do need to apologise. I've spent quite a bit of the last summer living on a yacht and sailing solo, so that tends to do things to your language because it doesn't necessarily have people feeding back to you that your standards are slipping. But I would just like to point out to my colleagues that on occasion, that was the backward button. On occasion, I was actually working when I was out on my boat. That's me marking a PhD thesis. All right, so here's my crazy, ambitious idea. I think it was really time that we worked a bit harder about breaking down the barriers that create the traditional silos in New Zealand science. We are a really small science community, and there are a lot of connections, but we do tend to have these dichotomies in what we do. So we have people that tend to work in the productive sector, or they work in the natural ecosystems. We have people that work in marine, or they work in terrestrial, or they work in freshwater. We have people work on indigenous knowledge or in the more traditional Western science. We have people siloed in CRIs versus universities, and we certainly tend to have people that are very focused in around particular taxa. So you might be focused on birds, or you might be focused on insects or plants or whatever. And I think, so my idea is really, it's not really actually all that novel, but really these systems in such a small science community aren't really all that helpful, and I think it perpetuates some of the issues that we have in working together and making sure that we're prioritising well and working collaboratively together. So one of the reasons that it is important to be working together is, as I said at the beginning, there's been massive changes in the environment in New Zealand. Oh, look, I can see there by not having to look up. That's easier on your neck. So you can, there's been these massive changes. So in about 1840, when my great-grandmother was around, it was largely forest cover, but now we're down to less than 23% indigenous cover. And that's fragmented right across the country. And of course, many of the species of concern, particularly invasive species, they don't care about those borders. Many of our species will quite happily wander between native forest or productive systems and create mayhem in all those areas. I just wanted to note that, of course, a lot of that fragmentation of the system happened as we the colonisation process happened in New Zealand, and so as we moved Māori communities, dissociated them with their connection with the land, that allowed us to go in and fragment and utilise those resources. So the whole thing's kind of interconnected. So we've ended up in New Zealand, similar to Australia, with really high proportion of our country is now in exotic grassland. And this graphic showing, is that one the pointer? It's a shame I can't work this. Does it have a pointer? Oh, try that one. Excellent, thank you. All right, so Australia and New Zealand at the top of the graph with lots of grassland, and in New Zealand's case, still a chunk of native forest and a few others. And that's perhaps a little bit different from many other parts of the world. So thinking internationally, there's been some, I think, quite significant moves really recently to think about the connection between people and the environment. And the UN's been, of course, thinking about human rights for a long time, but it was really only in March of this year that this piece of work was done that linked explicitly biodiversity and human rights together, so that the full enjoyment of human rights depends on biodiversity, and the degradation and loss of biodiversity undermine the ability of human rights, of human beings to enjoy their human rights. Of course, it's not the first time that's been thought of, and back in 2005, around the Millennium Ecosystems Assessment, had a lot to say about biodiversity and human well-being, but it's really good to see the Human Rights Council bring that to the fore. So part of that linking people and the environment is working out what are the factors and what do we do about trying to maintain biodiversity and good quality environments so that we can have those connections with people. So in this recent paper was looking at, well, what are those key components of global environmental change? And I think in New Zealand we focus an awful lot on invasive species for good reason, but globally, the overexploitation of species and agricultural activities are really high on that list. So the international context shifts slightly depending on where you are, but certainly for New Zealand, invasive species are right up there. And posing a threat for a huge number of our systems. Now, we'll try one of these live polls again, although I have to say when I'm working my phone, I singularly fail on getting in the number and everything. But can we have a go? Is anybody still with this program? Got your app? Come on, Bevan, you can do it. So the question is, how many native New Zealand species are at risk of extinction? And if you don't have your app, you can still have a guess. Are we down at the 50 end of things, or are we up around 900? How do we get an answer? Oh, we've got to wait for 30 seconds. Is it actually working this time? Yes. I should have brought my phone. I might have actually been able to do one. I know, the suspense is going, what was the answer? Calculating the results. There we go. What does that mean, Phil? So that means that
Half think 900.
half think 900. Good on you, folk. It's a sad that you are right. How do I move on to the next bit? Oh, we jumped several. This is awesome. You shouldn't give me too much technology. Most people have worked this out by now. All right, so the answer is more than 900 native species approaching extinction and another 2,800 declining or at risk. Only around 250 species are currently in conservation programs, but the problem with all those figures, of course, is we don't know for all species. There's a whole pile of things in New Zealand and internationally that just aren't assessed at all because we don't have names on things, we don't necessarily know what their ecological status is and whether they're going up or down or whatever. So we tend to know more about the large and obvious, the vertebrates and things, but there are a whole range of things that we don't know much about at all. So the Endangered Species Foundation, which I'm on the board for, has actually been doing some work around some of these lesser known endangered species, and they've put out this list of 10 of the lesser known but critically endangered species, such as the Chesterfield skink there, which is actually threatened by a range of factors, but including invasive species, through to lovely, look, how would you like, that can't possibly go extinct, that's awesome. Canterbury knobbled weevil, which is in a tiny area in Canterbury. In fact, we thought it had gone extinct, but thanks to some great work by Laura Young at Canterbury University, it was rediscovered. And so there's a desperate need to get on with trying to secure that population. And one more, if you thought the knobbled weevil was obscured, what about this freshwater plant, the endangered quillwort? Actually, that's in really serious trouble. It used to be found in several Northland lakes, but it's now considered to be extinct in the wild, predominantly because of a decline in water quality. So my point is that New Zealand biota isn't in particularly good shape. It's not just invasive species, obviously, that's causing the problem, and we've got a long way to go to reverse the trend for most of these things. Invasive species, though, obviously are an important issue for us, and it was great to see, again, a relatively recent international initiative coming out of the 2016 IUCN Congress, where for the first time they got put forward and accepted something specifically on invasive species. So a challenge that we need globally to take greater action on addressing invasive alien species. And again, for this link between biodiversity and human well-being. Okay, so what's New Zealand doing all about this? Well, we have this biosecurity system which we aim to be comprehensive in the sense that it goes from these international agreements through to pre-border, post-border, and including pest management. And so I guess the thing that I was wanting to consider here is, do we have that balance right between the overall comprehensiveness? So we're working on terrestrial systems versus marine, and we're working across native systems and productive systems. And although many of the issues are in common, there are sometimes when it's not. And again, I guess it comes back to what I was posing at the beginning about what I think our ambitious challenge is that if we're siloing the science into these different categories, it doesn't help when you're trying to then build this comprehensive system and drive it through to give good outcomes right across the sector. I don't actually, of course, have an answer to this, but I've got some examples that might prompt some thinking around it. So this is another live poll, and this time we will need the 30 seconds to think your way through this. And if you don't have your phone, I still want you to think through it. So this is I decided this would make an excellent question for my students in their exams, so they might get this year. But let's say, for instance, you now are all the biosecurity people, and you have to make a decision, all right? We've got a new incursion come in, and I know you're tired, it's the end of the day. Bad luck, that's what happens in biosecurity, right? You just can't hang up your clogs, right, and say, look, I'm tired, I've had a really busy day. They're on the phone, you've got to make a decision. You don't have a lot of knowledge. This is it, all right? We've got a new moth. It's in a small area of the South Island. You know, you've had your great diagnostics team have come in, and so they know what it is, and you've done a little bit of work around what it's going to cost farmers to try and mitigate against the impacts of this moth. So it's going to cost them around about $165 per hectare per annum, and you've had a chat to the people in the environmental circles and the DOC people and whatever, and they've worked it through, and they go, well, look, this is going to attack some native plants, and it's likely to cause some extinctions. And then you have to think, oh, well, that's all really bad, but what are you going to do about it? And so you're kind of stuck. Nobody's actually dealt with this pest. No one's achieved eradication anywhere in the world before. And it's looking like, you know, maybe it would cost you a lot of money, but we don't think it's going to work. Okay, so your job is, what are you going to do? Should we attempt eradication anyway? You know, good old Kiwi can do. Let's give it a shot. No one's done it before, but we could. So you have two choices, all right? You guys don't get to sit on the fence. Something's in the country and you've got to make a decision. You can't wait around for 10 years while we get the research in place to delimit it fully, to work out what the solutions might be. You've got to make a decision. So go, make your decision. You would, of course, have a little bit more information than this, but not necessarily a lot more. Now you're tired, I know you're tired, you've had multiple incursions to deal with in the last week. I know you've got, you know, the DG of MPI sitting on your back. You know, we spent a lot of money on incursions this year and don't want to have to go to Parliament to make a case for more money. You know, the minister's sitting in the back going, holy heck, you know, it's election year, we don't need this. Come on, guys, no pressure. What's it to be? Yes, you're going to go for it. You guys are so going to have the taxpayers on your back. You know, these things all have consequences. They're not easy decisions, and it is a fraught area. Okay, so we'll come back to, that's actually based, the MPI people will have recognised it, of course, it's based on an actual thing, so we'll come back to that in a moment. But one of the points is that things are at our border and coming in all the time. Mammals, not so much in New Zealand now. And I really like this graphic because you can see, here we go, the circles are Europe, and you don't want to be in Europe because look at all the mammals that are continuing to come in. But in New Zealand, we've, you know, not adding many, if any, new mammal species at this stage. It's not the same for all taxa, though. And invertebrates and pathogens in particular are knocking on our door all the time. Now, there's much better graphs out there than this that show it more widely, but I did this one on Vespidi wasps, so that's why you get this graph. But essentially, for many of these things, God damn it, for many of, oh shit, sorry. Look, there's only 4 buttons on this thing. You'd think I'd get it right. For many of these things, there's no sign in the accumulation curves dropping off that these things are continuing to spread globally and into New Zealand all the time. We stopped, well, this was published in 2011, so the last incursion there was Vespula vulgaris detected in Argentina, but you know, even in recent years we've had Polistes, another species of Polistes, detected that it was established in New Zealand last year. So these things are continually coming at us all the time. Okay, so some examples, some of which I've already mentioned. Giant willow aphid, we know, has come in recently and established. This is the European paper wasp that came in and has established. We only found it last year, but it was all obvious that it had been here for a wee while, and it was far too widespread to even attempt eradication at that point. Eucalyptus variegated beetles, now apparently established, although they may have another shot at this, who knows. Had a beetle, so this is not a comprehensive list. These are just some recent things that have come in. A little side, we've got time for a little side thing here. Because of copyright, I went looking. This is my own picture of Polistes diminula when I was in Italy, and because I was going through my old photos to find it, there's me in Italy being the responsible mother. Not. All right, moving on. But we are pretty good at eradicating some of these species that get here. This is the Pea Weevil that we've got a response going. Well, this is the we that I don't have at all. But MPI have a response underway at the moment, so we're hoping we've got a shot at getting rid of that. Queensland Fruit Fly, of course, keeps knocking out on our door. We keep detecting it. We keep eradicating it. Awesome. So to me, Queensland Fruit Fly is a real example of our biosecurity system working really well. We detect it, we eradicate it. They've let it go in Australia. We know it's going to keep coming our way all the time, but we actually have pretty good systems for dealing with it. Brown marmorated stink bug has been mentioned multiple times, potentially coming our way, especially now that we know that it's got a breeding population in South America as well. These things are just going to keep moving around. But so far, with the ones that have been detected arriving in New Zealand, they've been dealt with. Oh, God damn it. Sorry. I'll get it under control, probably not, by the end of the talk. And then the great white butterfly, of course, which I think has been one of New Zealand's stunning eradication success stories. So I'm going to talk about that a little bit more, because we should celebrate it when we do get it right. So this was a species that was found in Nelson in 2010, and then there was a long period while there was quite a bit of debate as to what to do. So this is actually the case that I gave you for you to make your decision on. And the original decision was made not to attempt eradication, and then the Department of Conservation came back at it and said, no, look, we're really concerned about the impact of this butterfly on our native brassicas. And so they took the lead and worked away at an eradication attempt. And so fortunately for New Zealand and for our native brassicas, you can see how well they have done. So the detection rate, so these things were confined to Nelson, and with the management that they were doing and some of the wonderful X-ray glasses that John Keane was talking about earlier, they focused in on the surveillance, and they managed to get the numbers down and down and down, and have now declared eradication. Woohoo, that's fantastic. I think it's also a really good case, though, of, and I'm sure people will over the next wee while, is to look at some of the assumptions that were made originally, because there was a lot of, what's the polite way of putting it, discussion about what we should be doing. And there were a number of cost-benefit analyses, but they were essentially suggesting that the probability of eradication success was not very high, probably around 30%, maybe as high as 60%. Of course, hindsight's a wonderful thing. We can now say, oh no, it was 100%, we can do that, but certainly at the time that wasn't thought to be the case at all. The cost of eradication was originally put at around 9 million. In actual fact, it cost about 5 million. So somewhere along the way, there was an awful lot of cost savings over what it thought could be done in terms of eradicating that species. But one of the key issues, of course, around the whole thing was trying to weigh up the economic costs of this butterfly, which was not particularly high, versus what were the cost to the natural environment around those native brassicas. And that's one of the issues that I think we're always going to really struggle with in New Zealand, because you can't put dollar values on a lot of this, or not easily. And so how do you value our native biota in a way that goes nicely into a cost-benefit equation? So I think that's an area where a lot more work needs to do, and these kind of examples are going to be really important to help us refine how we go about doing that. So that would be one area where I think I would conclude that the natural environment is a poor cousin in some ways, partly because of the difficulty of trying to put a value around natural resources. Okay, and part of that is, even if we could put a value around it, often we just don't know. We're guessing as to what on earth's going to happen if something new arrives into the community. So we have this really poor ability to predict which of these new species are going to have the really big impacts. And again, myrtle rust has been mentioned multiple times today. That's one where we can probably predict that there's likely to be really high impacts. The great white butterfly, as I was going to say, there was a bit of a doubt, and Sabella is another one that, you know. So with each of these, when they first arrive, it's just so difficult for many of them, in the absence of any information, to be able to put numbers on it and to help make really good decisions. So obviously the sort of information you need is partly around the species that has arrived on your doorstep, but it's also around interpreting in the context of where you are. So the recipient community, or the receiving land for these invasive species, there's two sort of generalisations we have. A is that invasive species tend to exploit the functional gaps in the native biota, and so an example of that would be, for New Zealand, a functional gap is that we don't have mammals. Well, we have a few bats, but by and large we don't have mammals in our system. And so anything that can exploit that gap is likely to get a foothold and do really well. So terrestrial mammals are a really obvious example for New Zealand, but there are many other gaps in our biota. For instance, New Zealand has no native social wasps or bees, which might explain why when social wasps got in, they've been, or partly explains why they've been so damaging. And we know that island ecosystems tend to be more vulnerable than continental systems. So New Zealand gets a double whammy with many of these things, just because of our isolation and the uniqueness of our flora and fauna. I also think there's huge taxonomic biases in the way we look at these things, and I've already alluded to that. Many of what we know about is the things that have been studied already, and we tend to study the things that are obvious and we can see. And so we know that invasive mammalian predators are really bad, and I'm not arguing that they're not really bad, they are. And that kind of thinking has, in New Zealand and many parts of the world, led to a huge emphasis on dealing with those mammalian predators, and there's lots of examples of how that's delivered some really astounding conservation gains if you can achieve that. And so predator-free New Zealand is kind of the next step along that journey for New Zealand, is trying to rid New Zealand of damaging predators by managing primarily possums, rats and stoats by 2050. But the cost of some of these other species is often not documented, but the Vespula wasps, there was a recent study had a go at trying to document that, and so that the cost to the New Zealand economy is estimated, see, they're both green. I think I'm colour. So the cost is around 130 million. So it's not an insignificant cost at all. So for some of these things, we need to do a little bit more work. Am I supposed to be finishing at 1:30?
Well, I've got more slides.
Yeah, no, that's all right. I'll just whizzy through a few. All right, so back to my point again about many of these things not having borders, and wasps is a really good example of this. They are a problem across a whole range of sectors, be it grapevine or the forestry industry or whatever, and of course people don't like them turning up at their picnics. Excellent. Oh, look at that. So we do know they have a really wide range of impacts on ecosystems, from predating insects and birds, competing for food, honeydew and other insects, and they disrupt the whole ecosystem processes as well by interrupting the flow of nutrients into the forest floor. So some of these species, they're widespread and they're impacting the environment in a whole range of different ways. We've studied wasps for many, many years, but there's still some surprises out there, and this was some work in looking at the Nikau flowers in mainland islands, and this wasn't supposed to be a wasp study. This was supposed to be looking at the recovery of the pollinator community as we controlled mammalian predators, but what happened was that none of those vertebrates that we thought might recover had recovered at all, and all we found turning up at the flowers of the Nikau were a whole pile of vespular wasps. So again, pointing to the importance of these things in some of our systems. There's a long way to get to the bottom of what all those vespular turning up at flowers might do. And so this piece of work that was done in Hawaii is actually really nice. Not the same species of vespular as in New Zealand, it's Pennsylvanica, but it's closely related. And it's also hoeing into the nectar produced by a Metrosideros, not our Pahudakau, but similar. And this study was found that by removing the wasps at those at a number of sites, they were able to get more of their native bees coming in. They ended up with a lot more honeybees on the flower, and they got an increase in the fruit production. So some of these things that we might otherwise tend to overlook can have a large impact in these systems. Okay, just I have a few more slides on wasps. One of the things that we know works really well against vespular wasps is poison baiting, because the wasp will take the poison back to the colony and you can bowl the whole colony. And so it's been great to see the development of this product in New Zealand, and in fact it's been used in a number of places around the world now. But it's not the only solution we need, and there have been a number of talks already today suggesting that what we need is more emphasis on some of these new technologies, and the National Science Challenge is doing exactly that, with using vespular as a model, developing some of these tools. And I'm not going to go into any of these things, but just to say that for many of these entrenched species, it's a long, hard road to develop these things. None of these things are going to be quick fix solutions, but unless we start the research, we're never going to get there. Then my bit of the research surprise is the eradication strategies, and somehow I needed to use my yacht to get to some of the offshore islands. It all works. All right, I'm going to skip this because we're going to run out of time. Actually, why don't we just go right to the end, which is here. So my final summary really is to say that our biosecurity system does need to be comprehensive, but I think we need to approach it holistically. We can't afford to divide up such a small science community into these silos. And we, after all, at the end of the day, we all do need to eat, but we all need to be considering what the environmental consequences of that might be. So, thank you, everybody.